Good morning, students. We will discuss about a topic of error, relative error. We consider first example of resistance. Resistance formula is R equal to V upon I. Example first. We have given value where V equal to 100 plus minus 5 volt and I current equal to 10 plus minus 0.2 ampere. These value we written as this type: V plus minus delta V, and I may be I plus minus delta I. Now what we find the percentage error in R, where R is resistance. We know resistance in resistance wire. On resistant wire we consider voltage. So formula there is given. Now this is V divided by I. So error in R is delta R upon R equal to delta V upon V plus delta I upon I. We know these formula. We read in previous lecture. This is dividation process. If we have dividation process and multiplication process, then error get same type: delta V upon V plus delta I upon I. Here delta V is 5, delta I is 0.2, V is 100, I is 10. So percentage error will be delta R into R 100% multiply by 100. So delta V upon V plus delta I upon I multiply by 100, which is in percentage. Then we take values. These values: delta V is 5 and V is 100 plus delta I is 0.2, I is 10 into 100. We get 7%. You see this result. Take we can calculate this formula very easy. This situation, this condition is very easy. So 7% is the percentage error in resistance. Now we consider second example. In which resistance there in series combination and parallel combination. First case is series combination, second case is parallel combination. Now we consider second example. Example 2. Two resistors of resistance is R1 equal to 100 plus minus 3 ohm, R2 equal to 200 plus minus 4 ohm. This value we can write this type: R1 plus minus delta R1, R2 plus minus delta R2. These resistance are connected in first case series combination and second case parallel combination. ठीक है? Now we find equivalent resistance in series combination and parallel combination. First case, the equivalent resistance in series combination. We know the equivalent resistance formula, R dash equal to, now here we get R dash is second, in second case लेंगे R dash को, तो R is R1 plus R2. We can be write R1 plus minus delta R1 plus R2 plus minus delta R2. Now we get result R1 plus R2 plus minus delta R1 plus delta R2. Now we put values of these R1, R2 and delta R1 and delta R2. So R1 is 100 plus R2 is 200 plus minus delta R1 is 3 plus delta R2 is 4. Then 300 plus minus 7 unit is ohm, because this is equivalent resistance. We get result of series combination. Now we consider second case of parallel combination. Parallel combination. Resistance same. We consider R dash. We know the result of this R dash is R1 and R2 upon R1 plus R2. R1 and R2 upon R1 plus R2. We get this result from 1 upon R1 plus 1 upon R2 equal to 1 upon R dash. This step we took direct. हमने ये direct step लिया है. So we consider the values 100 into 200 and 100 plus 200. Now 2 0 0 0 4 0 and 300. 200 upon 3 ohm. This symbol is for ohm, we know. Now error. We know the formula of parallel combination. 1 upon R dash equal to 1 upon R1 plus 1 upon R2. For change, we take differentiate this formula. Differentiate करेंगे हम इसको. First of all, we write this equation as this type: R dash power minus 1 equal to R1 dash to power minus 1 plus R2 raised to power minus 1. Now we consider differentiate. We know differentiate method. If x and x raised to power n, then differentiate, we get result n x n minus 1. Power minus with minus 1, पावर में से एक कम हो जाएगा, ठीक है ना. तो now we take this formula here: minus 1 and R dash minus 1 and delta R dash. We take this. Now minus 1 R1 minus 1 delta R1 plus minus 1 R2 minus 1 subtract with minus 1 delta R2. You understand the each point of my lecture. If any problem, you comment on this video. So minus minus minus, these minus are cancelled. Now R dash raised to power minus 2 delta R dash equal to R1 raised to power minus 2 delta R1 plus R2 raised to power minus 2 delta R2. Now we get formula for error: delta R dash upon R dash square equal to delta R1 upon R1 square plus delta R2 upon R2 square. These 200 upon 3 ohm, this value of R dash. Now error delta R dash equal to R dash square delta R1 upon R1 square plus R dash square delta R2 upon R2 square. We take values, we put the values of these quantities. R dash is 200 upon 3 square into delta R1 is 3 upon R1 square is 100 square plus R dash is 200 upon 3 square. Delta R2 is 200. Delta R2 is 4, not 200. Delta R2 is 4 upon 200. This is in square. Now 200 square cancel out. 20 square cancel out. Now we get delta R dash equal to 2 into 2 upon 3 into 3 into 3 upon 1 plus 4 upon 3 into 3. Three into 3 LCM, we take LCM. Now 9 4 12 है 16 आ जाएगा. 16 divided by 9, we get 1.77. Significant, this number. 7 is more than 5, so we add in 7 by 1, so 1.8 ohm. Now we get the result. आपने ये सब लिख लिया होगा. We remove these lines. Result is R dash equal to R dash plus minus delta R dash. We get 200 upon 3 plus minus 1.8. 200 divided by 3, we get 66.66 plus minus 1.8. Now we write this result as this type. 66.7. 6 is more than from 5. So we add 1 in 6. We get 66.7 plus minus 1.8 ohm. This is final result. Equivalent resistance in parallel combination. आप ये वीडियो दोबारा से रिप्ले करके इसको समझ सकते हैं. इफ यू डोंट अंडरस्टैंड एनी पॉइंट, you will be write the comment on the video. We will give you reply of the comment. If you understand the all points of lecture, then like and subscribe this channel. Now we start new topic. Error in a measured quantity raised to power. We consider example Z is equal to A raised to power 2. We will write this step A into A. Now error in Z, delta Z upon Z, and this is in multiply form. Now A, delta A upon A plus delta A upon A. We get result 2 into delta A upon A. Now we consider a definition. Definition is the relative error in a physical quantity raised to power k is k times the relative error, k times the relative error in divisible quantity. We have K is 2, then 2 into delta A upon A. This definition is clear. Now we consider a example of this type problem. Find the relative error. Example, find the relative error in Z. Z is a raised to 4 b raised to power 1 upon 3 c raised to power 1 over 1 d raised to power 3 by 2. Now we get relative error in Z. Delta Z upon Z. This is result final. This is final result. A raised to power 4, then 4 times the relative error in A. 4 times relative error in A. 4 into delta A upon A. B raised to power 1 upon 3. 1 upon 3 times the relative error in B. Now C is 1 times relative error in C. Now we get in D relative error 3 upon 2 delta D upon T. This is the final result of this Z error. Now we consider another example of periodic time T. We know periodic time is one oscillation time is periodic time. We consider an example last in video and stop this video. If you like, you comment on this video. Example is the period of oscillation of a simple pendulum is T equal to 2 pi into L upon G. This is the formula of T. Measured value of L. L की वैल्यू है 20 सेंटीमीटर. Known to 1 millimeter accuracy. 1 millimeter accuracy. Time for 100 oscillation of pendulum is found to be 90 seconds using a wristwatch of 1 second resolution. So T for 1 oscillation, here is given 100 oscillation. So we divide by divide these values by 100. 90 upon 100 प्लस माइनस रिजोल्यूशन दे रखा है 1 सेकेंड का 1 अपॉन 100 सेकेंड. वी गेट t इक्वल टू 0.9 प्लस माइनस 0.01 सेकेंड and L equal to 20 centimeter plus minus 0.1 centimeter. What is the accuracy in the determination of G? T is equal to 2 pi L upon G. We get G T square equal to 4 pi square L upon G. G equal to 4 pi square L upon T square. ठीक है, this is dividation problem. We get this result with same time result आएगा, same type. Error in G, delta Z upon Z, L divided by T square. We get error delta L upon L plus 2 into delta T upon T. We put values of delta L upon L and delta T upon T. Delta L is 0.1. L is 20 plus 2. Delta T is 0.01 and T is 0.9. We get 1 upon 200 plus 2 into 1 upon 90. We get 1 upon 200 plus 1 upon 45. We get 245 upon 200 into 45. We get the final result in percentage error, because we will be get percentage error. So percentage error in G is delta Z upon Z into 100. So 245 into 200 into 45 into 100, we get 2.7. 3%. 3% is the percentage error in G. G is the acceleration, gravitational acceleration. We see all the relative error problems. If you understand each topic of lecture, you share this video. So thank you very much.